The next is component diagram. A component diagram is used to break down a large object-oriented system into smaller components so as to make them more manageable. It models the physical view of a system such as executables, files, libraries, etc. that resides within the node. It visualizes the relationship as well as the organization between the components represented in the system. It helps in forming an executable system. A component is a single unit of a system which is replaceable. A component of a single unit of a system which is replaceable and executable. The implementation details of a components are hidden and it necessitates an interface to execute a function. It lacks a black box whose behavior is explained by the provider and required interfaces. Purpose of the component diagram: visualize the component of system, construct executable by using forward and reverse engineering, describe the organization and relationship of the component. Next is benefit of component diagrams. Component diagrams are very simple, standardized, and very easy to understand. It is also useful in representing implementation of the system. These are very useful when you want to make a design of some device that contains an input-output socket. Use of reusable components also helps in reducing overall development cost. It is very easy to modify and update implementation without causing any other side effects. How to draw a component diagram? Before drawing a component diagram, the following artifacts are to be identified: files used in the system, libraries and other artifacts relevant to the application, relationship among the artifacts. After identifying the artifacts, the following points need to be kept in mind. First is use a meaningful name to identify the component for which the diagram is to be drawn. Prepare a mental layout before proceeding the using tools. Prepare a mental layout before producing the use tools. Prepare a mental layout before producing the using tools. Use notes for clarifying important points. The next is package diagram. A package diagram is a type of unified modeling language diagram mainly used to represent the organization and the structure of a system in the form of packages. A package is used as a container to organize the elements represent in the system into more manageable unit. A package is used as a container to organize the elements present in the system into a more manageable unit. It is very used to represent the system architecture and design as a cohesive units and concise manner. Purpose of package diagram. Package diagram can be used to simplify complex class diagram. It can group classes into packages. A package is a collection of logical related UML elements. Packages are depicted as a file folder and can be used on any of the UML diagram. Benefits of a package diagram. They provide a clear view of hierarchical structure of the various UML elements within a given system. These diagrams can be simplified complex class diagrams into well-ordered visuals. They offer valuable high-level visibility into large-scale projects and systems. Package diagram can be used to visually clarify a wide variety of projects and systems. These visuals can be easily updated as a system and project evolve. How to draw a package diagram? Perform the steps below to create a UML package diagram in Visual Paradigm. Select diagram, new form the application toolbar. In the new diagram window, select package diagram. Click next. Enter the diagram name and description. The location field enable you to select a model to store the diagram. Click OK. So these are the steps to draw a package diagram. Next is deployment diagram. The deployment diagram visualizes the physical hardware on which the software will be deployed. It portrays the static deployment view of a system. It involves the nodes and their relationships. It ascertains how software is developed. It ascertains how software is deployed on the hardware. It maps the software architecture created in design to the physical system architecture where the software will be executed as a node. Since it involves many nodes, the relationship is shown by utilizing communication path. Purpose of deployment diagram. This shows the structure of runtime system. They capture the hardware that will use to implement the system and the links between the different items of hardwares. They model physical hardware elements and communication path between them. They can be used to plan the architecture of system. They are also useful for documents the deployment of software component or nodes. Benefits of deployment diagram. Clarity in the system architecture. Next is communication and collaboration. Identification of hardware resources. The last is fault detection and troubleshooting. Clarity in the system architecture. Deployment diagrams offers a clear and concise overview of physical architecture of a system, including hardware devices and the relationship between them. Communication and collaboration. They serve as a communication tools between different teams involved in the development process. Identification of hardware resources. Deployment diagrams help identifying the hardware resources required for the system. This includes servers, databases, communication infrastructure, and the other physical components. Fault detection and troubleshooting. By visualizing the deployment architecture, it becomes easier to identify potential points of failure and troubleshoot issues. How to draw deployment diagram. Decide on the purpose of the diagram. Add nodes to the diagram. Add communication association to the diagram. Add other elements to the diagram, such as component or active objects if required. The last is add dependencies between the components and objects if required. Next topic is relational model. The relational models provide a standard way of representing and querying data that could be used by an application. From the beginning, developer recognized that the chief strength of the relational database model was in its use of tables, which were intuitive efficient, and flexible way to store and access structured information. Another strength of the relational model emerged as a developer began to use structured query language to write and query data in database. For many years, structured query language has been widely used as a language for database queries. Based on relational algebra, structured query provides an internally consistent mathematical language that makes it easier to improve the performance of all database queries. In comparison, other approaches must define individual queries. How relational databases are structured. The relational model means that the logical data structure, the data table, views, and indices are separate from the physical storage structure. This separation means that database administrator can manage physical data store. This separation means that database administrators can manage physical data store without affecting access to that data as a logical structure. For example, renaming a database file does not rename the table stored within it. The distinction between logical and physical also applies to database operations, which are clearly defined actions that enable applications to manipulate the data and structure of the database. Logical operations allow an application to specify the content it needs, and the physical operations determine how the data should be accessed and then carries out the task. To ensure that data is always accurate and accessible, relational databases follow a certain integrity rules. For example, an integrity rules can be specified that duplicate rows are not allowed in a table in order to eliminate the potential for information entering the databases. Next is relational model and data consistency. Relational model is the best at maintaining data consistency across the applications and database copies called instances. For example, when a customer deposits money at an ATM and then looks at the account balance on a mobile phone, the customer expects to see that deposit reflects immediately in the updated account balance. Relational databases excel at this kind of data consistency, ensuring that multiple instances of database have the same data all the time. It is difficult for the other type of databases to maintain this level of timely consistency with a large amount of data. Some recent databases, such as NoSQL, can supply only eventual consistency. Under this principle, when databases is scaled or when multiple users access the same data at the same time, the data needs some time to catch up. Eventual consistency is acceptable for some uses, such as to maintain a listing in a product catalog, but for crucial business operations, such as shopping cart transactions, the relational database is still a gold standard. Relational language. Relational query language is used by the user to communicate with the database user requests for information from the database. Relational algebra breaks the user request and instruct the DBMS to execute the request. It is the language by which the user communicates with the database. They are generally on the higher level than any other programming language. These relational query languages can be procedural and non-procedural. There are two types of relational query language. One is procedural query language, the other is non-procedural query language. We will discuss one by one. Procedural query language. In procedural query language, the user instructs the system to perform a series of operations on the database to produce the desired results. Users tell what data to be retrieved from the database and how to retrieve it. Procedural query language perform a set of queries instructing the database management system to perform various transactions in a sequence to meet the user request. Relational algebra is the procedural query language. The next was non-procedural query language. In non-procedural language, user outline the desired information without giving a specific procedure or without telling the steps by steps process for attaining the information. It only gives a single query on one or more tables to get. The user tell what is to be retrieved from the database but does not tell how to accomplish it. For example, get the name and contact number of a student with a particular ID will give a single query on a student table. Relational calculus is a non-procedural language. This is an example of non-procedural language. The next topic is relational systems. The term relational system in the context of database management system typically refers to a system or model that implement a relational data model. The relational model is a way of structuring data in tables with row and columns. Relational database management systems are software systems that implement the principle of a relational model. Here are some key aspects of relational database system in the BMS. Tables and data organization. Primary key and foreign key. Normalization. Structural queue language. The last is ACID properties. In today's lecture, we discuss about the enhanced unified modeling language, relational model, and languages and systems. Now let us access your knowledge and track your progress with a few questions. These questions will allow you to revise the topic, and make more clarity on the today's lecture topic. So the question for the today's lecture to test your knowledge are: what do you mean by unified modeling language and explain by detail? Explain component diagram in detail. Describe benefits of package diagram. What are the procedure query language? Explain in detail. In our exploration today, we have gone through the world of data modeling using the unified modeling language, relational model, peeked into the language and systems. Today, we understand the most important topics of database management system, including unified modeling language. I hope you enjoyed this lecture. So keep it up your study, and I will see you all in the next lecture. Thank you very much.